Thank you, everyone. Sorry about the interruption. There are some technical problems here. So my name is Terry. I work at Wave. You can see the logo there. I also help organizing this event this year and last year, so I hope you're enjoying yourself. Thank you. So the talk I'm going to give today is abstractions. And the reason I wanted to give this talk is because I think there is a bit of confusion around this concept. So when I try to Google what is abstractions and how to approach them, I give usually like the first thing to pop up is what is the difference between encapsulation and abstraction, which is totally two different things. And those answers like give you very vague and general idea about it. So I'm gonna try to make it more concrete and less abstract. Okay. So this is a content. I'm gonna define what this is. I'm gonna give some examples, and then we're gonna go through some features and how to approach them. So the definition. So there are many definitions you can find online in many books, but all of them can be basically, this is the best I can find. That's all I'm saying. So it's the concept of moving the focus from details and concrete implementation of things to features that are relevant for a specific purpose, this is important, with a more general and abstract approach. So you can say it's a concept of generalization as well, but the word itself comes from Latin, to draw away. So basically, you try to draw away attention from the concrete implementation of things to the things you want to present, basically. So take something very complex and make it simple. That's the basic idea. So there are some very arbitrary examples over here. And I tried to be as random as I could. So the first thing that pops to mind when it comes to abstractions, why do we need abstractions in a software development? Well, obviously it's to abstract things that we don't have in software science, right? We don't have object, there's none of this in the software, right? But we can abstract it, we can model it, we can build behaviors around it, and that way we can basically implement all that inside of software. So that's the first thing that comes to mind when you try to talk about abstractions and why you need one. But that's not the only thing that abstraction can do. There are different kinds of abstractions. The protocols, HTTP, TCP, UDP, you name it. This is the abstraction tree layer of the internet, basically, right? And each one of those is an abstraction in itself. Again, an arbitrary example, Django ORM or any ORM, for that matter, is also an abstractions. It takes something more complex and makes it more simple and more compatible to whatever you want to use it for. So in this case, we have ORM on the right side. We have whatever database you want to use, relational. And I also put SQL here because it's also an abstraction. Is this, like when you do a query, is this actually how it works underneath? No, it's an abstraction. It basically makes the usage simpler and more abstract without worrying too much about the implementation, how you actually should approach them. They'll move closer to Python. Basic data structures, also an abstraction. Because how many of you know how the list is implemented in Python? like how is it actually implemented on the interpreter level? Many of you know? Raise your hand. Exactly, like you don't have to know how it's implemented to use it because it's abstracted for you. Is it simple? No, it's actually probably very complex, and there are a lot of people who are binding their minds to actually achieve the same result. Python itself is an abstraction because, like, if you're talking those are all abstractions, then basically Python is an abstraction, and any language for that matter. And your favorite framework is also an abstraction. So there you have it. Everything is an abstraction. So this is, I try to give an example more concrete. Not very concrete, it's still very abstract. But this is a typical example of MVC model application that all you are probably familiar with. And these all are basically all your levels of abstraction. So as you can see, started from the bottom, there's a Python. There's also binary because that's how it works. There's nothing in between, which is not true. But this is the power of abstraction. You don't have to worry about what is in between this. It just works for you, right? And this is the basic level of abstraction you start to work with when you, when you basically code in Python, right? So this is, like, it doesn't have to be this model that you probably want to use, but it's very popular. And this is another layer of abstraction of your application you might have. So model, view, and controller. If you code in Django, you probably call it model, template, and view. But this is how you scale your abstraction. So basically, you don't have to worry about the implementation of how you store or how you retrieve the data. This is all handled in your model and the modeling itself. The view is basically how you want to present your data, and controller takes what data you should be presented. And on top of that, you basically try to scale your application in one way. So this is a very simple example. But perhaps it's not enough. You want another layer of abstraction. And this is another approach to scale the application more complex. You have your implementation abstractions, which take care of how you want to model, share, view, and store your data. But that's not enough because that's the details of your implementation. You might have more complex things to worry about, like domain abstractions, because like we all write applications that are meant for something outside of the software development, right? And we made them for users, and users have their own ideas of things. So we might wrap this thing in an interface or a service or both, and this would be another level of abstraction. And yeah, so this is more complex. And then if you want to scale it more, you can have you multiply it by n, and you have your distributed system. So there you have it. This is your abstraction tree. Very scalable, I would say. Each component, the important thing, each component has its own role in this tree. There is no no repetition of what the thing it should do. So yeah. So next slide. I actually put that like 10 minutes before because that's the first thing I can find online. And this is not an encapsulation. So what I mean by the encapsulation. If you take, like you find in your code, a block of code that is really huge, and you basically copy that code, sorry, cut that code from there, try not to break the scope, paste it, wrap it in some other function, or if you want to go object-oriented, wrap it in an object, fix all the names, make it work. There you go. You just encapsulated some piece of code into its own function and object that is completely like distant from where it was before. But this is not an abstraction. There's no abstraction around it. If you want to, there's no simplification, because if you want to actually know what's going on, you have to go into that function, go into that object, and figure out what the hell is going on here. So first thing is, as I mentioned, abstract application design. Each component, like the diagram before, knows what it's supposed to do. It's isolated, provides only necessary details to the upper level abstractions. The examples would be data validation, TCP connection handler. All right, we don't have time. So I'm just gonna take 1 minute and go through the slides. Okay, we don't have it in 1 minute. All right, well, thank you. If you can find me